Hello my dears. So today we are going to discuss a very important session in power system, which is nothing but the unsymmetrical fault in a power system. So before that you have to clearly know what is the meaning of symmetric as well as unsymmetrical fault, my dear. So listen, the word symmetry means there will be 120-degree phase angle between voltages as well as currents in a three-phase system even after the fault occur, my dears. So fault may be classified as generally fault may be, we can say that what are the types of fault you may usually encounter in a power system. Faults actually, what are the faults actually? A line to ground fault may happen, a double line fault may happen, a double line to ground fault may happen, a triple line to ground fault may happen, or a triple line fault may happen. These two faults now, triple line to ground fault, that means if three of the conductors fell down to ground, then it is called a fault. If the three of the conductor connected together due to some reason, it may be due to heavy wind or anything. Okay, if three of the conductor come in contact together, then these two type of fault na, triple line to ground as well as triple line fault, it is called the three-phase fault. It is called, my dear, three-phase fault. And what is the peculiarity or what is the speciality of this three-phase fault is that among all this fault, my dear, only these two faults now, this is called the symmetric fault. This is called the symmetric fault. And this is nothing but, my dear, unsymmetric fault. This LG, LL, LLG. Na? LG means a single line fell to ground. LL means two lines come in contact to each other. LLG means two lines fell to ground. So these three faults are called unsymmetrical fault. And why the name, my dear, symmetric as well as unsymmetric? That means even if the fault occur after that also, if the voltages in three phases, that means VA, that is the voltage across phase A, VB, which is nothing but the voltage across phase B, and VC, which is nothing but the voltage across the phase C. These three will be in symmetry with respect to each other or balanced voltages after the fault. That means they will maintain 120-degree phase angle even after the fault occur, my dears. Even after the fault occur. That means these three voltages are in same balanced condition, what it to be before and what it after. That means before the fault, we know that the three phases are balanced voltages. Balanced voltage vectors means both the magnitude, not the instantaneous value, magnitude, as well as the phase angle between these three vectors are 120-degree each other. That is called the balanced three-phase supply. The total magnitude of VA, that is mode VA equal to mode VB equal to mode VC. That is called the magnitude of the voltage. 240 volt means each phases contain 240 volt. Is it clear? So this is called the balanced supply. So what is symmetrical fault means, my dear, even after the fault, the system will be in balanced condition. That means the magnitude of the voltage doesn't change after the fault, and the phase angle between the three voltages, again they will keep 120-degree phase difference with respect to each of three phases. Then what is the fault? What is the meaning of fault? Only the fault current increases, my dears. The fault current increases. So these three faults now, this is called the symmetrical fault. Why? Because the voltage phase angle as well as the magnitude of voltages will remain same even after the fault occur. But the rest three faults now, LG, LL and LLG, that is the line to ground fault, line to line fault and double line to ground fault. These three faults are called unsymmetrical fault. Why the name unsymmetrical means these will not follow this. That means after the fault occur in the power system, if that fault may be any of these three, any one of these three fault occur in a power system, the phases, that means the voltages, will not be in 120 degree with respect to each other. That may be, the phasor may be VAB like this, VBB like this and VCB like this. That will not be make an angle of 120 degree with respect to each other. And you might have noticed one thing also, my dear. See, yes, it will be more clear now. It will be more clear. The magnitude of the voltages VA, VB and VC also not equal to each other. But there the magnitude of voltages are equal. Now I can say that mode VA not equal to mode VB not equal to mode VC, and the angle of VA not equal to angle of VB not equal to angle of VC, which is not equal to 120 degree, which is not equal to 120 degree. So that type of fault is called, my dears, unsymmetrical fault. That means after the fault, the three phases or three voltages loses its symmetry. Loses its symmetry means loses its balanced nature. Loses its balanced nature. So our area of focus is more on this unsymmetrical fault, because this fault is actually very frequently happening faults in the power system. This three-phase fault now, this is just 5%, my dear, 5% or 3 to 5%. Nearly 3% of possibility is there in three-phase fault. But rest of the three faults now, the most frequently happening fault is this one. This one is the most frequently happening fault, and after that this fault, and after that this fault, and after that this fault. So a one-word question maybe you can expect from this session is that what is the order of occurrence of fault, or order of possibility of occurrence? That is the correct word, my dear. Possibility of occurrence of fault. So order of possibility of occurrence is most possibilities line to ground fault, and after that it will be line to line, after that line to double line to ground, and after that triple line or triple line to ground fault. And order of severity, my dear, this is also very important question. Order of severity of fault. Order of severity of fault. This is nothing but the reversal. That means least severe is the line to ground fault, after that line to line fault, after that double line to ground fault, after that triple line to ground or triple line. So this is the order of severity first. These two questions, might is very important. These two questions are very important. That means what is the order of possibility of occurrence? That most possible, I mean, we are frequently seeing what type of fault means it will be line to ground fault. You might have also noticed the same thing now. One line is fell to ground. That fault is, we are commonly see that type of faults in and around us, right? So this LG fault is the maximum possibility of occurring fault, type of fault, and this LG fault is the least severe fault. So these two differences now, you should definitely take care of these two differences. Is it clear, my dears? So now we are going to discuss what is or how can we calculate the unsymmetrical fault current. unsymmetrical fault current, because only by the knowledge of the fault current we can design the circuit breaker, we can design the relays. Okay, is it clear now? So we have to know what will be the method, or how can we find the unsymmetrical fault current. That is very difficult. Three-phase fault current, symmetrical fault current means it will be again in balanced condition, so that we can easily calculate the fault current after the fault. But for unsymmetry, see, these are the vector. This is how can we find the resultant from this one? It's a very difficult. It's a tedious task, so that we can make a resultant voltage, make a resultant current, make a fault current from all these, from this unbalanced vector. It is very difficult. It's very difficult. So what we have to do? That method is called the symmetrical component method. It's very important, and it's very important. Symmetrical fault or symmetrical component. Symmetrical component. I will explain now. So next we have to see symmetrical component. So unsymmetrical fault, and under subheading symmetrical component. See, my dears, so I already told you that. So before we take into symmetrical component, what is mean by phase sequence? Phase sequence is nothing but, my dear, the order at which the alternating quantity that may be V or I attains or reaches, that is the correct word, reaches its maximum value. That means there are two types of phase sequences, my dear. I will explain one thing. This is VA, this is VB, this is VC. And suppose this is a balanced three-phase supply. Okay, imagine 120-degree phase angle between them. And always the phases are assumed to be rotating anti-clockwise direction, my dear. Phases are assumed to be rotating anti-clockwise. Always we have to take the anti-clockwise rotation of the phasor. That is a conventional method. So suppose I put a stationary object here. Imagine I put a stationary object here. While rotation, I put a stationary object here. Okay, here. So what phasor will hit first? The stationary object. Which phasor will hit first? The stationary object. This stationary object. A will hit first now. And after that, what will hit this stationary object? If it is in anti-clockwise direction, after A, B will hit. And after B, my dear, C will hit. So this is called the ABC phase sequence. That's all. That's all. And another phase sequence also there. So again anti-clockwise direction, and this is also 120-degree phase angle. And this is, suppose I put a stationary object here. I placed a stationary object here. What phasor will hit the stationary object first? First A will hit, definitely I know. After that C will hit now. After that C will hit now. After that only B will hit if it is in anti-clockwise direction. So this is called ACB phase sequence. So there are two types of phase sequence, or generally we can take the phase sequence in such a manner that if I place a stationary object anywhere, or the order in which it hit the stationary object is called the phase sequence. Is called the phase sequence. So there are two type of phase sequence normally in the three-phase system. That is possibility now. Either ABC or ACB. That is the only possibility. No other possibility is there, right? So ABC phase sequence or ACB phase sequence. That knowledge you should have first. That knowledge you should have first. Okay. That knowledge you should have first, my dear. Okay. So come to the symmetrical component. So symmetrical component is a tool actually, my dear. It's a tool. It's a mathematical tool. For what is the purpose of the symmetrical component means any unbalanced vector. My dears, any unbalanced vectors can be resolved into balanced components. Any unbalanced vectors, my dears, can be resolved into balanced components. That is called the symmetrical component. I will explain. See, so this is VA, VC, maybe so by simply looking into the diagram, it is clear that these three vectors not balanced, right? It is unbalanced. Unbalanced means, my dear, it will change its magnitude. I mean, the magnitude of three vectors will not be equal, and also the phase angle between them will not be same. It will vary. Then it is called an unbalanced vector. So this unbalanced vector, my dear, this unbalanced vector can be, it is equal to the sum of VA1, VB1, VC1 plus VA2, VC2, VB2 plus VA0, VB0, VC0. See, my dear, the beauty of the symmetrical component resolving is that any unbalanced vector, now, my dear, these can be split into three vectors such that each vectors can be, suppose this VA1, VA2 and VA0. If you add this VA1, VA2, VA0 vectorically, my dears, vectorically, that means, which implies that this VA can be equal to VA1 plus VA2 plus VA0, and VB can be equal to VB1 plus VB2 plus VB0, and VC can be equal to VC1, VC2 plus VC0. So among these, this VA1, VB1, VC1 all are called positive sequence. And see the nature of VA1, VB1 and VC1. Why this is called a positive sequence means it is in ABC phase sequence. Correct now? After A, after B and after C. Is it clear? And each will having a phase angle of 120 degree. So these three vectors are positive sequence, ABC balanced vectors. Same manner, this VA2, VB2 and VBT also negative sequence. It is negative sequence, that is ACB balanced vector. And this is called zero sequence balanced vector. Actually, a very interesting thing you might have noticed. Actually, when I was a student in my BTech, I didn't know the thing, that is the beauty of the zero sequence. Actually, you know, my dear, these three zero sequence now, A0 and B0, C0, this is actually overlap to each other. A0 before, after that B0, and after that C0. When you're looking from here, it will simply seem like a single straight line. So in order to know, in order to the understanding purpose, for understanding purpose only, we have to split it into three and each having a phase angle of 0 degree in between. So that is also balanced now. VA0, VB0, VC0 both having same magnitude. The meaning of balanced means, my dear, VA1 magnitude, VB1 magnitude and VC1 magnitude will be same. Incidence value may be different. VA2, VB2, VC2 magnitude will be same, but incidence will be different. VA0, VB0, VC0 magnitude will be same, as well as the phase angle between these vectors will be also, my dear, same. Phase angle will be same means 0 degree between 3 also a same phase angle concept, correct? Phase angle between 120 means it's a balanced vector. Phase angle between these three is 60 means we can also say that it's a balanced vector. But 60 is not possible. It can be. 60 is 180 degree in simply 360 degree we have to make. So it is that, no, it's not possible. 0 is possible. No? There is no phase lag between three vectors is a possibility. So that is a balanced vector. So listen, my dear. So what we studied now, very carefully, please observe this very carefully. If you have any unbalanced vector in your hand, you can split up into three set of vectors, my dear. Actually, these three set of vectors are balanced. So that is, if we have a balanced supply in my hand or balanced vectors in my hand, then very easy to find the resultant, fault current, everything you can easily find. Okay, or I can pictorially I will explain one more thing, my dear. If I place VA here, I will show you now. If I place this VA here, my dear, if I place my VA here, suppose same, okay, VA1, and if I place VA2, my dear, VA2, so VA1 and VA2, simply like this, VA2, and also I place VA0, it is horizontal now, VA0. See, the resultant 3 will be VA, that's all. If I place my VB here, my dear, so here is VB now, so if I place my VB here, so VB here, okay, so I can represent like I can represent like this. VB1 and VB2, this VB2, this is VB1. The same manner you can draw VB, this is VB1, BV1 I draw, and VB2 and VB2 also draw, and VB0, see, VB0 horizontally, VB0. If you are drawing with the help of a software, electrical software, exactly you will see the magic. Exactly you will see the beauty of this symmetrical resolution. If I place each of these, suppose if I place VA1, VA2, VA0 here I will definitely form VA. I will definitely form VA. If I place my VB1, VB2 and VB0, the resultant will be VB. That is the beauty. That is the beauty. So that is the meaning of resolution. That is the meaning of resolving a vector, my dears. Resolving a vector. So what we learn now? So any unbalanced vector can be resolved into three balanced vector. That is called the what, my dear? Symmetrical component. Okay. And I will tell you one more thing. Next, the operator A. Another important concept from this session, the operator A. That means, my dear, you have three vectors right now. Right now you have three vectors. Right now you have three vectors. In ABC phase sequence, okay, VA1, VB1, VC1, all having 120 degree phase angle between them. Okay, my dear, can you tell me? I can say that this VA1, this VB1, with respect to VA1, it is 120 degree lagging. Magnitude may be same, but the phase angle is actually 120 degree lagging. And this VC1, with respect to VA1, it is again 120 degree lagging, so total 240 degree lagging. Total 240 degree lagging. So I can say that, my dear, VA is equal to some magnitude V, the same actually angle 0. VB equal to some magnitude minus 120, and VC is equal to some magnitude, that is the same magnitude, minus 240 degree. So the operator A means nothing but, my dear, A is nothing but one angle 120 degree. One angle 120 degree is represented as A. One angle 120 degree is represented as A. So I can say that VA1 will be 120 degree leading with respect to VB1. Same manner. And VA1 is 240 degree leading with respect to VC1, that also you can say. So A means nothing but, my dear, one angle 120, that is the magnitude of one with phase angle 120 degree. It is an operator, my dear, it is an operator. Okay, the A means one angle 120 degree. And what will be A square? What will be A square? A square is nothing but one angle 240 degree. A square is nothing but, my dear, A into A. If you multiply one angle 120 into one angle 120, angle will be added. Magnitude will be simply multiplied. So one angle 240, that is the A square. That is the A square. And what is A cube? It is one angle 360 degree, or simply 1. Or I can say that another identity, 1 plus A square equal to 0. This is very, very important identity, my dear. Very, very important identity. How this identity obtained, I will tell you. One angle 120 means what? One angle 120 degree means, I can say that R angle theta. What is R angle theta? Cos 120 plus J sin 120, which is nothing but, what is cos 120? Cos of 90 plus 30 plus J into sin of 90 plus 30, my dears. Am I correct? Or I can say that, my dear, cos 90 plus 30, if it is 90 means sin will become cos, cos will become sin, sin 30, and 90 plus 30 means it's in second quadrant. Second quadrant means after school, so sin is only positive, cos will be negative, so the result will be minus sin 30 plus J into sin 90 plus theta. It is simply cos theta, and in second quadrant sin is positive, so it will be cos 30 only. So it will be minus 0.5 plus j 0.86. So this is the value of, my dear, A, which is nothing but one angle 120 degree. And A square means it is nothing but one angle 240 degree. One angle 240 degree. So if you have this one angle 240, if you take this one angle 240, you can again multiply like cos 240 plus j sine 240. So the answer will be, you can check, it will be minus 0.5 minus j 0.866. That is equal to A square. That is equal to A square. So you have A now, you have A square now. 1 plus A square will be definitely 0. So why I told you all this? Why I told you all this, my dear? Why I told you all this? Because if you have to represent, I will tell you. If you have to represent the unsymmetrical component in symmetrical component, resolving manner. See, my dears, that means we have a relationship, like we can form a matrix like this: VA and VB and VC equal to 1 1 1 matrix, 1 A square A, 1 A square. This is very important matrix, my dear. Only you have to remember this matrix: VA0, VB0. This is the relationship between the voltages. The VA, VB, VC are all, my dears, what? Unbalanced vectors. These unbalanced vector can be resolved into 3 balanced vector. By how? By this. This can be written like VA equal to, my dears, VA equal to VA0 plus VB, VA0 plus VB0 plus VC0 plus BA will be equal to A1, A2, A0, correct. VA1, VA2 and VA0, VA1, sorry my dear. VA0, VA1 and VA2, correct. So this VA can be write like VA0 plus this into this, yes, VA2, and VB can be equal to, see, VA will be equal to, my dear, 1 into VA0 plus 1 into VA1 plus 1 into VA2, and VB will be equal to again VA0 plus A square into VA1 plus A into VA2. Similarly, VC will be equal to VA0 plus A into VA1 plus A square into VA2. It's very, very important relationship. That means you just need to know this matrix, my dear. Just need to know this matrix. So why I introduced the A there? Because A only can say to us that there is a 120 degree lag or lead between these two phase quantities. Magnitude can be easily available, my dears, but for making a system balanced, the phase sequence should be 120, 120, 120. So what is the indication of that 120? That is nothing but our A. That is nothing but our A. If you resolve this, I will tell you one thing. See, my dear, VA will be equal to, the phase VA will be equal to VA0 plus VA1 will be correct, na? If you add the sequence component together, you will get VA, correct, na? VB will be nothing but VA0 plus A square into VA1 plus A into VA2. If you put the value of A square and A here, my dears, you will get the same VB now. Same VB now. That means if you have VA0, VA1 and VA2 in your hand, and if you want to find the unbalanced VA, VB, BC, substitute it in this matrix, you will get the answer. Okay, and if you have VA0, VA1, VA2, that means if you need to find VA0, VA1, VA2, then this will be slightly modified like my dear. Both you should know, both relationship you should know. You just by heart these two matrices, then easily this three-phase fault can be calculated. This will be slightly confusing now, don't worry, just focus on these two matrices. Okay, when we are solving the line to ground fault, line to line fault, double line to ground fault, etc., definitely these things can be applied there, so that it will be very easy for you then. So if you have in your hand VA, VB, VC, if someone asks you to resolve this into the positive sequence of A, zero sequence of A, positive sequence of A, and negative sequence of A, simply 1 by 3 root 3 times 1 1 1 this matrix. You just mug up these two matrices, my dear. This is very important. You just muck up these two matrices, then symmetrical fault is over actually. If you muck up this matrix, then symmetrical fault can be easily understandable. Is it clear? So from these also you can say that VA0 will be equal to 1 by 3 into VA plus VB plus VC. Okay, and VA1 will be equal to 1 by 3 into VA plus AVB, A square VBC, A square VC, and VA2 equal to 1 by 3 into VA plus A square VB plus AVC. So this also you have to keep in mind. So if you know this, you can easily derive this relationship. No problem at all. Is it clear, my dear? So slightly it may be confusing. I know that. So why I introduced A means the purpose of A here is nothing but, my dear, in order to represent that phasor is lag 120 or lead 120. That phasor is lag 240 or lead into 240. In order to represent that lagging or leading by 120 degree, we have something. That something is called the operator A. That's all. That something is called the operator A. That's all. That relation 1 plus A square equal to 0 and A cube equal to 1. That relationship definitely you should keep in mind. So one word question also you can expect from that relationship. Directly you can expect from the relationship. Okay. Or simply what is the value of A? Also many examination I have seen that value of A will be asked, A square will be asked, A cube will be asked. So that is nothing but A is 1 angle 120. That's all. Not minus 120, it is 1 angle plus 120. Okay, so from next class, in the next class we will discuss about each and every unsymmetrical fault in very detail. In very detail we can expose, and we can apply this there and we'll find the fault current, so that these things will be more and more concrete there. So thank you so much.